Greetings, mathematicians. Pretty excited because I really like this lesson that I'm going to be going over with you today. And this is my 20th video. I can't believe it. I just looked at my PowerPoint and I'm on my 20th slide. So it's kind of amazing that that we've been through 20 different videos and information as we've gone along here this school year. And so let's go ahead and get going. Yeah, I bet you can get this one. I had to think about that one. I'm like, okay, I get it. All right, let me get it set up here. And big screen here. All right, first, I'm going to go over the notes and then I'll show you how to fold it or you can cut it. So we'll go over that later. But the first definition I'm going to go over is angle addition postulate. Now it's going to be very, very similar to our addition segment postulate that we went over the other day. Instead of a segment, well, today we are doing angles. And you've already learned about the 4 different type of angles: acute, obtuse, right, and straight. And you'll probably be using those as we do some of our problems today. All right, so go ahead and flip it over. The definition: if K is in the interior of Hij, then the measure of Hik, okay, that would be this measure right here, and then the measure of Kij, this one right here. So I could even number them. This is angle 1 and this is angle 2. So both of those together are going to give you Hij. Okay, so yeah, that kind of makes sense. And we're talking about the interior of those angles. And so let's go over and take a look at an example. So we have that the measure of AOC, angle AOC, is 74. Now that's the whole thing. So I'm going to just put 74 degrees right here. I'm kind of just doing a little arrow. So it's going to be AOC, the whole angle is 74 degrees. Now, AOB, it's not a specific degree. It's an expression. I'm going to put that 2x plus 11 in where that AOB, angle AOB would, it is located. And then we have that the measure of BOC, remember O is our vertex, and that is just x. All right, so we got to think about what is it that we need to do here to get this thing solved. Well, we're going to add these 2 angles together, and those 2 angles together should equal 74. So we have to set up an equation. So let's go ahead and do that. 2x plus 11 plus x equals 74. Now, I have a calculator handy. And so I would suggest that you do that too. We're going to be doing some different calculations, and I think it's going to be helpful. Well, this is just an algebraic equation that you probably saw last year, especially first semester when you were solving different types of equations. Now I'm going to get my like terms together. 2x plus x is 3x. So I just always would call that, hey, let's clean it up. We've got to clean up the equation before we start getting our constants together, getting our like terms together on each side. So 3x plus 11 equals 74. So I cleaned it up. Now it looks like a 2-step equation. I'll subtract 11 from both sides. And I end up with, it looks like 63. 3x equals 63. Now we're down to a 1-step equation. I'll divide by 3. And x equals 21. Now that's just for the value of x. We still do not know what the degrees are equal to. We'll get to that here in just a second. All right, let me put 21 up here. That's x. Now we know that BOC is just X. Oh, okay, so BOC is actually going to be 21 degrees. AOB, because it's 2X plus 11, that's an expression, I will need to substitute in 21 in for X. And then it's an order of operation problem. 2 times 21 is 42 plus 11. So then I know 42 plus 11 is going to give me 53. That will be the measure of AOB. And don't forget the little degree sign. Now, if I add that together, that should give me 74 degrees. And yes, indeed it does. 1 plus 3 is 4, 2 plus 5 is 7. And that's what the whole big angle was equal to. So I know I solved that correctly. One other term that we're going to go over is angle bisector. Now, bi means two. Bicycle has two wheels. And so a bisector is going to split a angle into two congruent parts. Okay, so on this one, our ray that is the angle bisector is XZ. Okay, and that's your bisector. It is bisecting WXY. And what you'll see sometimes is you'll just see if this is one arc, this will be one arc. And they use that to indicate that those two angles are equal to each other or the same degree or congruent. So I know congruent can be, it's like, yeah, what does that mean again? And it just means equal angles, equal degrees for those angles. All right, so let's take a look at another example. Again, it's going to be kind of a mystery here. We're going to have a lot of information. It definitely does help to put that information in the picture, and then we'll see what we can come up with for an equation. Okay, so let's take a look. We've got that FG bisects EFH. So I'm going to put those arc marks so that I know that those two are going to be equal to each other. We've got that the measure of GFH is 4x minus 32. I want to make sure I get that in the right spot. EFG, that's the other angle, is 2x plus 8. Now, that's all they give us. Okay, so I was like, oh, okay, so what can we do? How can we set up an equation? Well, we know that this is a bisector, and so these two angles are going to be equal to each other. And I know a lot of times kids are like, why do we have to solve equations with variables on both sides? Well, here's a great example. We're going to set this up, and we have to be able to solve an equation with variables on both sides in order to figure out what x is and all of our missing degrees for these angles. So let's get to it. I like keeping my x term positive, so I am going to subtract 2x from both sides, just like keeping that term positive. All right, so that cancels. I'm left with my constant of 8. 4x minus 2x is 2x. Bring down my minus 32. Well, I need to get my constants together, so I've isolated my x term, need to get my constants together. So I'm going to add 32 together, or 32 to both sides. You always do those inverse operations. Okay, let's see what we have. 40 equals 2x. Now this is always, I think, the easy part here when you're just down to one step. You can always do this by inspection, but the inverse of timesing by 2 would be to divide by 2. And we get that x is equal 20. Now that's just x. I mean, that's not a degree or anything. I'm going to fill it in right here. All right, so now we need to find GFH. And it's an expression, 4x minus 32. I'm going to substitute 20 in. And 4 times 20 is 80. Minus 32. And I think I'm going to get 48 for that. 48 degrees. And I'm going to fill it in. Yeah, that looks like it'd probably be about a 48-degree angle. All right, EFG. Now we know that these two angles are congruent, but I'm going to be a good mathematician and I'm going to substitute in just to make sure I get the same degree. So EFG is 2x plus 8. I'm going to substitute 20 in. That's what my x is. Oh, awesome. 2 times 20 is 40 plus the 8. 48 degrees also for EFG. Yes. All right, awesome. I know that I have that. Now, EFH. Okay, so now I can use my angle addition postulate. Now I know that this is 48 degrees. This one's 48 degrees. I can add those together to get EFH. And 48 plus 48 is 96 degrees. Whew, okay, I am almost done. All right, so the last one is IFE. And we know from the other day, a straight line is how many degrees? Think, 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 think. Yes, yes, yes. It's 180 degrees. So if I know that right now I've got 96 degrees here, it's like, well, how much more do I need to get 180? So I'm going to go over on the side here, 180 degrees minus 96. And I'm going to borrow here. And I believe it should be 84 degrees. So I'm going to just type it in real quick just to make sure I've got that right. 80 or 96. Yes, 84 degrees. All right, so that would be, I'm going to go ahead and label it there. So right there, it would be 84 degrees, which it kind of looks like it would be. Now we got to remember that these aren't necessarily drawn to scale, but 84 degrees is a little bit less than 90. So yeah, that kind of makes sense. If I would have got an answer like 120, I'd be thinking, I'm not sure if I got that right or not. So I think you can see that I think these are fun. These are like little puzzles. Kind of have to see what you've got, try to set up an equation. And yeah, we're going to do some practice on this. And you'll just get better at recognizing different parts of the angle that you can use to set up an equation. All right, to finish this out, you can just fold this like a booklet. Okay, so I've got it folded. I'm just going to cut the dashed area. I want to keep this like a booklet. Now, I've had other students in the past, they've cut kind of all the way through, and then they glued the top on one page and they glued the bottom on the other. But I'm just going to keep it together so I can just open it like that. So I grab my notebook, find a new page here. Here's all my other notes. And remember, I still see a lot of you just slop and glue on. Really, all it takes is just 4 little dots in the corner or a thin line. Some of your notebooks are starting to get really thick. You're really using too much glue. That's really all we need, guys. Okay, 4 dots of glue or a thin. Can show you just a thin line all the way around. I like using thin lines too. I've been doing this for a few years, so cutting and gluing. I know it's kind of psycho, but I love doing both of them. All right, here we go. And it's all set. All right, so now you can look in there. You've got 2 great examples for each of those definitions. And we'll do some more work.